We're going to review the second part of the Unit 11. Now, for this part, we're going to need some formulas. First, let's talk about the angle sum or the difference identity to find the exact value of each. Couple things you must need to remember. I gave you guys the sum and the difference formulas, right? If you're adding or subtracting in sine or you're adding or subtracting in cosine, make sure you remember these formulas. Also, I gave you something called the unit circle. Make sure you remember those values from the unit circle. I'm going to be using the formulas I just showed you, and the numbers from the unit circle. So let's take a look at our work. Sine of negative 105. Now I'm thinking, two numbers that I add or subtract that is equal to negative 105. I'm just going to go with negative 105. Let me go 30 minus 135. I'm going to do sine of 30 minus 135. Right. 30 minus 135 is negative 105. So from the unit circle, I was thinking, all right, two angles that I add or subtract, in this case subtract, and it's equal to negative 105. According to the formula that I gave you guys, I have sine of A minus B. I'm just going to have this as sine of 30 times cosine of 135 minus cosine of 30 times sine of 135. Now, I'm going to use the unit circle. Sine of 30. Sine of 30 is 1/2. Cosine of 135 is negative radical 2 over 2. Cosine of 30 is radical 3 over 2. Now, sine of 135 is radical 2 over 2. So looking at my first fraction, my two fractions, I'm going to multiply my first two parentheses. So I'm multiplying the top, positive 1 times a negative radical 2, going to give me a negative radical 2 over 4. Then I have minus radical 6 over 4. Now the negative from the first fraction is right there, right? That's where the first negative came from. All right, so I'm going to combine it into one whole fraction since I see the common denominator. The denominator is 4, so on the top I'm going to write negative radical 2 minus radical 6. Now in red, let me do it here on the top. I'm going to type in, the way I'm going to do this, I'm going to do a big parenthesis for the top. I'm going to do negative radical 2 minus radical 6. Don't forget your parentheses. See how many parentheses I have. And all this is over 4. Now let's take a look at question number 26. I'm thinking either add or subtract two numbers that when you add them or subtract them is equal to 105. And the only angles you can choose from are the angles that we have in the unit circle. So in my case, I'm just going to do cosine. Now the two numbers I'm going to add that is equal to 105, I'm going to go 60 plus 45. Now a couple things I want to emphasize. For question number 25, when we subtract, order does matter. 30 minus 135 is different from 135 minus 30. So in subtraction, the order does matter. In addition, 60 plus 45 or 45 plus 60 is not going to make a difference. All right, so here I'm going to use the formula that I gave you guys of cosine A plus B. So I have cosine of 60 times cosine of 45 minus sine of 60 times sine of 45. That's from the formula. Now using the unit circle, cosine of 60 is 1/2. Cosine of 45 is radical 2 over 2 minus sine of 60 is radical 3 over 2. Sine of 45 is radical 2 over 2. Okay, my first two parentheses, let me multiply those. Looking on the top, 1 times radical 2 is radical 2. Now looking at the bottom, 2 times 2 is 4 minus radical 6 over 4. I combine this into one whole fraction. The denominator is 4. And then I have radical 2 minus radical 6. The way I'm going to type this, let's go in red. A big parenthesis for the top. I'm going to go radical 2 minus radical 6. All this is over 4. All right, not too difficult. Now, some cases, some of you guys might have the different order. What I mean with the different order is instead of having radical 2 minus radical 6 over 4, some of you guys might have negative radical 6 plus radical 2 over 4. You might have that. Notice how on the top, the order switched. Just keep in mind, things kept the sign. Some of you guys might have that. Same thing for number 25. Some of you guys might have a different order, like negative radical 6 minus radical 2 all over 4. Now, the order on the top, as long as you keep the signs, the order on the top it's okay for you to move it around. Okay, so now let's review questions 27 and 28. Convert each decimal degree measured into degrees, minutes, seconds, and each degrees, minutes, seconds into decimal degrees. So if it's given to us in degrees, and I'm in decimal, I'm just going to start with 167 degrees. Now my point forward, I'm going to multiply this by 60. Keep in mind I said multiplied. Multiply by 60, point forward, so just the decimal part, times 60 gives me 24. So 24 minutes. I have no decimal. So now I'm just going to say 0 seconds. If I did have a decimal, multiply the decimal part by 60. So multiply by 60. So 167, you guys can see where I got that, 167 degrees. Now the decimal part, 0.4 multiplied by 60, gave me the 24. If after that I still had a decimal part, the decimal part multiplied by 60 again to get the seconds. Now going backwards, I'm gonna start at 21. 21 divided by 60. It gives me 0.35. So let me write my steps. 21 divided by 60, it gave me 0.35. Then I look at the minutes, and I'm just going to say 52.35 divided by 60. That gives me 0.825. So, matter of fact, let me just write 0.8725 because that's what it gave me. That gave me the decimal part. Now, before the decimal, I'm just going to write 181. And you guys can see where I got that from, the degrees. Now, I have 181.8725. So that's not that bad. Now, let's take a look at 29 and 30. Let me remind you guys of the double angle formulas and the half angle formulas. Make sure you guys have those formulas. Okay, so now that I refresh your mind, let's take a look. So use a double angle or half angle identity to find the exact value of each expression. So looking at sine of theta over 2. My formula, according to my formula, I have plus or minus. My plus or the minus will be depending on the quadrant where I'm at. Now plus or minus 1 minus cosine of theta over 2. And all that fractions is inside my square root. Now, I know when I covered this section, sometimes I did my right triangle to find my opposite, my adjacent, my hypotenuse, because I needed to either find a sine, a cosine, a tangent, depending on the formula. Now, for this one, I just need to find out what's cosine of theta, and I'm given cosine of theta. So I don't need to do my right triangle to find out the 3 sides of my triangle. For the moment, let me just worry about the fraction. I'm just looking at 1 minus cosine of theta over 2. So I'm looking at this as 1 minus 12 over 13th all over 2. So I'll worry about the square root at the end. Right now, I'm just looking at that fraction. Now, my 1, let me write this as 13 over 13th. I wanted to write it as a fraction such that those two fractions have a common denominator. Now, let me write this as, let me simplify the top, 13 over 13 minus 12 over 13th. That is 1 over 13th. Over, let me write this as 2 over 1. I want to write it as a fraction over a fraction. The reason why I want to do that, because when I have a fraction of 2 fractions, I'm going to write this as 1 over 13th times 1 over 2 times the reciprocal of the fraction at the bottom. That gives me 1 over 26. Remember I said I was just worrying about the fraction. Now I'm going to worry about the square roots. And as a matter of fact, I'm going to do the square root on top and the square root at the bottom. So that gives me 1 over radical 26. Okay. I cannot have radicals at the bottom. So one thing I'm going to do to get rid of radicals at the bottom, let me multiply top and bottom by radical 26. So that gives me radical 26 over 26. Now, let me write this right here. Radical 26 over 26. And I said it's positive or negative depending on the quadrant. Let me go back to our unit circle. Sine, if I notice, remember my first, when I have my values, my x value, that's my cosine. And my y value, that's my sine. Now, looking at the question that we have, we are in the first quadrant. How do I know? Because it says theta is between 0 and 90 degrees. So sine on the first quadrant. Looking at the signs from the first quadrant, they all have a positive sign. In that case, my answer is positive. How do I type this? Radical 26 over 26. Let me review a little about the signs. You can tell the x value tells you cosine. The y value tells you sine. So that way you know whether your cosine is positive, whether your sine is positive or negative. Now tangent, because I only see cosine and tangent, and sine, I mean. Tangent now you have to remember tangent. There's a fraction. Tangent is a fraction. We're dividing both of them, cosine and sine. Tangent. One thing I want you guys to remember is tangent is the same thing as sine divided by cosine. Now, real quick, notice I'm going to be dividing my x and my y values. Remember, x is cosine, y is sine. I'm going to be dividing y divided by x. If the signs are the same, I'm talking about first quadrant, third quadrant. Right? First quadrant, I have positive divided by positive. In the third quadrant, I have negative divided by negative. In the first and the third quadrant, tangent is positive. Now, when it comes to the second and the fourth quadrant, when cosine and sine have a different sign, in those cases, tangent is negative. Some of you guys might struggle on that still, so just wanted to review that a little. All right, let's go back to our work. Let me remember the formula. I gave you guys formulas. Remember, I just showed you guys the formulas. The formula for tangent of theta over 2. The formula that I gave you guys is positive or negative, depending on the context, the square root of 1 minus cosine of theta over 1 plus cosine of theta. Seems like I need cosine of theta, and I am given cosine of theta. So at this moment, let me just worry about the fraction. I'll worry about the square root at the end. I have 1 minus 4 over 5. And then at the bottom, I have 1 plus 4 over 5. And then my 1, I'm going to write it as 5 over 5. So I have 5 over 5 minus 4 over 5. And 5 over 5 plus 4 over 5. That gives me 1 over 5 over 9 over 5. And then from here, I'm just going to do 1 over 5 times 5 over 9. My 5's cancel out. And I have 1 over 9. Now, let me worry about the square root part. So just as a recap, I have 1 over 9. Let me do the square root part on each. And that gives me 1 over 3. So just have 1 over 3. Now I have to remember, is it positive or negative? Think about this. This is in the third quadrant. The fourth quadrant. How do I know? Because it says theta is between 270 and 360. Let me even remind you guys. I'm in the fourth quadrant. tangent in this case is negative. So my answer in this case, I have negative 1/3. How am I going to type this? Negative 1/3. Not too bad. Let's finish our review here. Now, for these remembered, questions 31 through 38, remembered the law of sines and the law of cosines. Let me remind you guys of those rules. We have the law of sines, the law of cosines. When am I going to use the law of sines? When I have two of the same letter. Like I have side A and angle A, or I have side B, angle B, or I have side C, angle C. When I have two of the same letter, I'm going to use law of sines. When I don't, I'm going to use the law of cosines. So let's take a look. I'm going to call this side A, this is side C, and this is side B. One thing from geometry, I remember that 3 angles of a triangle equals 180. If I'm given 2 angles, I can easily find a third angle. I'm given 2 angles here, 137 and 26. Add those up, 137 plus 26, that gives me 163. Subtract that from 180, and that gives me 17. That means that angle B is 17. Now notice I have angle B and I have side B. Remember I said when I have two of the same letter, I'm going to use law of sines. I'm going to say 18 over sine of 17 is equal to, I'm solving for BC, the distance between B and C, and that is little a, over sine of 137. When I cross multiplied, I have that 18 times sine of 137 is equal to a times sine of 17. To get the a by itself, I'm just going to say that I have 18 times sine of 137 divided by sine of 17 is equal to a. Notice how I divided both sides by sine of 17, just to have the a by itself. All right, so I'm going to worry about the, let me see, let me grab a calculator, let me have it here. So I'm just going to type in 18 times sine of 137. In this calculator, I have to type in sine first. Notice how it's having it there. So I put it all inside parentheses. That way I know that's the whole top, 18 times sine of 137. And I'm going to divide this by sine of 17 equals, I have 41.98. So the 8 I know pushes the 9, and the 9 pushes the 1. So I'm going to call this 42 or 42.0. I have to round to the nearest tenth. Let's take a look at question number 32. I'm given two angles, 108 and 34. If I add the two angles, 108 plus 34, that's 142. Subtract that from 180, and I'm going to find out that the third angle is 38. I'm going to say this is little a, this is little b, and this is little c. Side A is opposite from angle A. Side B is opposite from angle B. Side C is opposite from angle C. Notice how I have two of the same. I have angle C and I have side C. I'm going to use law of sines. Remember I said when you have two of the same letter, use law of sines. So I have 11 over sine of 38 is equal to, all right, I'm solving for AC, the distance between A and C. That's little b. So I'm going to write this as b over sine of 34. When you cross multiply it, you have that 11 times sine of 34 is equal to b times sine of 38. Divide both sides by sine of 38. So I have 11 times sine of 34 divided by sine of 38 is equal to b. Remember, all I did was divide both sides by sine of 38. That way those cancel out. All right, so I'm just going to grab my calculator. And I'm just going to go open parentheses. Have 11 times sine of 34, close parentheses. All of this is divided by sine of 38. Remember your calculator, sometimes you might have to press sine and then 38. Sometimes you might have to press 38 and then sine. Depends on your calculator. Also on your screen, make sure you have it on degrees. You see on my top right, it says DEG for degrees. Make sure you have it on degrees. All right, so I'm just going to press equal. I guess this is processing. Okay, 9.99. Have to run it to the nearest tenth, one decimal place. In this case, I have 10 or 10.0. Either way, it will be accepted on the homework. Now, what if I have to solve for an angle? Now, I remembered if I had two angles, it was easy to find the third angle. Now, I don't. Now, here, I'm just going to say that what I have here is I see angle B, side B, because I'm going to label this side A, this is side C, and this is side B. I have angle B and side B. I'm going to use law of sines. So I'm just going to say that 23 over sine of 81 is equal to 15 over sine of A. I have no idea what angle A is. That's what I'm solving for. When I cross multiply it, I have that 15 times sine of 81 is equal to 23 times sine of A. In order for me to get sine of A by itself, let me divide both sides by 23. So I have that sine of A is equal to 15 times sine of 81 divided by 23. That's sine of A, keep in mind. So let's take a look. Okay, so let's find out what that fraction is. Let me clear all this. So 15, oh, I forgot my parentheses at the beginning. 15 times sine of 81, close parentheses, divided by 23. I double check that that's what I want. 15 times sine of 81 divided by 23. Press equal. That's what sine of A equals. Sine of A. So I have that sine of A is 0.644144 and some more numbers. Sine of A. How do I figure what angle A is? I have to do sine inverse of that. So I'm just going to do now this calculator is called the arcsine, which is sine inverse. Your calculator might have it as a sine to the -1. It looks like an inverse. So I have to do sine inverse or arcsine. Some people call it arcsine of 0.644144. There were some more decimals, but I'll just leave it at that. Round it out to one decimal place, 40.1. Going slow in these cases because I want us to review really good. Okay, so here I notice I'm going to label my sides. This is little side A, this is little B, and this is little C. And I notice I have side B and I have angle B. Law of sines. I'm going to use the law of sines. I'm going to say that 41 over sine of 90 is equal to 30 over sine of A. When I cross multiplied, I have that 41 times sine of A is equal to 30 times sine of 90. So I have that sine of A is 30 times sine of 90 divided by 41. All right, so open parentheses. On the top, I'm going to go 30 times sine of 90. Make sure that's what I have. Okay, good. Divided by 41. So sine of A, I have this 0.731707. I'm going to do at least 6 digits. That's sine of A. Now I have to do arcsine or sine inverse. And so your calculator can even call it arcsine or can say sine to the -1. Arcsine of 0.731707 equals 47.02. I have to run it to one decimal place. 47.0. When it's 0.0, it's okay if you just write 47. Not hard. Let's take a look at example number 35. I'm going to call this side A, little a, this is little b, and this is little c. Now, I notice that I don't have side A, angle A, or side B, angle B, or side C, angle C. I don't have two of the same letter, so I have to use law of cosines. Depending on the angle that I gave you guys. I gave you guys angle B. So we're going to use the formula that's from the law of cosines. We're going to use the second one. Let me law of cosines. I'm going to use the second one since this is the one that has angle B. So I'm going to use the second one. I have B squared is equal to A squared plus C squared minus 2 times A times C times cosine of B. So I have that B squared, I don't know what little b is equal to 20 squared plus 6 squared minus 2 times 20 times 6 times cosine of 46. All right, so let me just go 20 squared plus 6 squared. Notice I'm literally just typing it all. Minus 2 times 20 times 6 times cosine of 46. So I have 20 squared plus 6 squared minus 2 times 20 times 6 times cosine of 46. And it tells me, when I press entered, it tells me that b squared, keep in mind, b squared is 269.28. 269.28 1991. That's b squared. That means that b, because I'm going to do the square root in this case, I'm going to do the square root of 269.281991. It says 16.40 rounded to one decimal place, 16.4. Now, if I look at the work that I'm solving for, it says find AC, the distance between A and C. Isn't that little b? So good, I'm done. 16.4. All right, let's take a look at number 36. This is little a, this is little c, and this is little b. I don't have two of the same letter, so I'm going to have to use law of cosines. I'm given angle C, so from the formula that I gave you guys, I'm going to use the third one, because that's the one that has angle C, right? Because I have to do cosine of C. So remembering the formula, I have C squared is equal to A squared plus B squared. A squared plus B squared minus 2 times A times B times cosine of C. Okay, so I don't know what C squared. I don't know anything about little c. Now, A is 19.4, so I have this as 19.4 squared plus 18.7 squared minus 2 times 19.4 times 18.7 times cosine of 121.2. Look like mumbo jumbo, but we have to type it in all anyway, so it's all right. Can deal with that. Make sure that I have what I need. So I have 19.4 squared plus 18.7 my calculator just froze. So 18.7 squared minus 2 times 19.4 times 18.7 times cosine of 121.2. Just make sure that's what you have. Boom. 1101.909676. 909676. When I'm working, at least I'm going to type in the first 6 decimal places. Now I have to do the square root of that. So I'm going to do the square root of 1101.90. The calculator just froze. So 909676 equals, so B equals 33.2. Right, I'm running it to 1 decimal place. So I have 33.2. Now here I was solving for the distance between A and B. Oh, and this is not B squared, actually this is C squared. So that's what I was solving for, so 33.2. Good, got it. Now let's take a look at number 37. Now, I don't have 2 of the same letter. That means I must use law of cosines. Now in this case, I don't have an angle. However, I'm solving for angle C. So I'm going to use the law of cosines. I'm going to use the last formula, the one that has angle C. I will have to figure what that angle is. So according to a formula, I have C squared is equal to A squared plus B squared minus 2 times A times B times cosine of C. I'm going to call this little side C, this is little a, and this is little b. Remember, side A is opposite from angle A. Side B is opposite from angle B. Side C is opposite from angle C. So I have that 14 squared is equal to 28 squared plus 24 squared minus 2 times 28 times 24 times cosine of C. I have no idea what angle C is. That's what I'm solving for. Now, 14 squared, let me simplify things a little. 14 squared is 196. Right? I cannot type everything all just at once because I have on the right side of the calculator, I have a letter C. I don't know what angle C is, so I'm just going to simplify things a little. I have 196 equals 28 squared is 784. 24 squared is 576 minus, now 2 times 28 times 24 is 1,344 cosine of C. Let me simplify even more. 784 plus 576 is 1,360. So I have that 196 is equal to 1,360 minus 1,344 times cosine of C. Let me subtract 1,360. I have that negative 1164 is equal to negative 1344 cosine of C. Let me divide both sides by a negative 1,344. So I have that 0.866071 is equal to cosine of C. Once again, let me write down what I just did. I divided each side by negative 1,344. So that's how I got the 0.866071 was cosine of C. Now let me grab my calculator. How am I going to solve for cosine of C, for angle C? I'm going to do arc cosine, or cosine to the negative 1. So I have arc cosine of 0.866071 rounded to the nearest angle, so 1 decimal place. That gives me 30. So angle C is 30 degrees. Let's work question number 38. This is little a, this is little b, and this is little c. I don't have an angle, so I will have to use law of cosines. I'm solving for angle b, so therefore from the law of cosines, the three formulas I gave you guys, I'm going to use the second one, because that's the one that has angle b. So I remember my formula. I have b squared is equal to a squared plus c squared minus 2 times a times c times cosine of b. All right, so I have that 6 squared is equal to 20 squared plus 17 squared minus 2 times 20 times 17 times cosine of b. I know what 6 squared is, right? 6 squared is 36. 20 squared, that's 400. 17 squared, that's 289. Now 2 times 20 times 17, I'm just going to call that 680 cosine of b. So I did 6 squared, I did 20 squared, I did 17 squared, and I did 2 times 20 times 17. Now I can simplify 400 plus 289. So I have that 36 is equal to 689 minus 680 cosine of b. Let me subtract 689. Now 36 minus 689 is equal to negative 653 is equal to negative 680 cosine of b. Let me divide both sides by a negative 680. And I have 0.960294 is equal to cosine of b. Let me grab my calculator. So I'm going to do arc cosine, or cosine to, it looks like cosine inverse. Your case might look like cosine to the negative 1. So cosine of 0. Let me see, my calculator just froze for a minute. 0.960294 rounded to 1 decimal place. The 9 is going to move the 1 over. So I'm going to call this 16.2. So angle B is equal to 16.2. Whenever you type it, just type in the number 16.2. Now on the test, we're only going to have one of these. But I just wanted us to practice. Now the last part, we're going to graph. So a couple of things I must remember. Sine. How does the graph of sine look like? There's 90 degrees. There's 180 degrees. There's 270 degrees. And there's 360 degrees. I said, before when I covered this, I said that a whole period, it takes 360 degrees to repeat. And I mentioned that sine, goes up to 1 and goes down to negative 1. It starts at 0 At 90, it reaches 1. At 180, it reaches 0 again. At 270, it reaches -1. And at 360, it goes to 0 again. And then it repeats. Right? It looks like a wave. It keeps on going on and on. That's how sine looks like. Now, my amplitude is the number in front of sine. Technically, there's a 1. I'm going to multiply it. My amplitude in this case is 1. My amplitude is 1, so it's not going to increase. But if there was a number, I don't know, if I had something like, let's say I had a 5 here, my amplitude is 5. So it goes up to 5 and as low as -5. But in this case, it's 1. And then my period. How long does it take for the whole cycle to repeat? I'm looking for the number in front of theta. For period is 360 divided by that number in front of theta. It's a 1. So it's going to take 360 degrees to repeat all of these. So to begin with, just to know how it started with, it started at 0, at 90 degrees, and it went up to 1, at 180, at 270, and at 360. And then obviously starts repeating again. That's how it originally looks like, sine of theta. My amplitude did not switch. It just went up to 1 and down to 1 to -1. My period is not going to switch. All right, so it's not going to change. Now my shifting is going to go 2 down. So let me start by moving everything, all my points, 2 down. So now it's there. So everything moved 2 down. And then I'm going to shift it 135 degrees to the left. Now, notice that 2 spaces is 90 degrees. So wouldn't 3 spaces be 135? Because each little square is 45. So I'm going to move everything 3 squares to the left. So let me go in blue. I'm moving each of my points 3 to the left. So that's going to give me something like move everything 3 to the left. So I don't have this one. So it goes there we go. Now let's take a look at cosine. First, let me remind you guys how cosine looks like. Originally, 0 degrees, 90, 180, 270, and 360. It starts at the 1, and it goes up to negative, going down to -1. This is how it looks like. I gotta think of what's my amplitude. My amplitude is 4. Is the number I'm multiplying by either sine or cosine. So it's going to go, in this case, it's going to go all the way up to 4. It's going to go down to -4. My amplitude is 4. What's the period? It's 360 divided by 2. So it's going to repeat in 180. All right, so let's see what I have at this moment. So at 0 degrees, it's going to go up to 4. In 180 degrees, the whole cycle is going to repeat, because it's 180, right? Because like periods. Now 45 degrees, or I'm looking at 180. Originally 180 is -1. So at 90 degrees, it's going to be at -4. Now 45 degrees, and then here. So that's what I have right now. That takes care of the amplitude and the period. Now the shifting. Everything is going to move 2 spaces up. So let me move everything 2 up. So I don't have these red anymore. I moved everything 2 up. And then let me move to the left -100. Let me move to the left 120 degrees. That means I'm going to move to the left 4 spaces. So this one moved, that one goes off the chart. And we're moving 4 spaces, so that one moved. So this one I removed it, this one I removed, this one I removed, and that one goes off the chart. And then let me move this one also 4 spaces. So this one moved, this one moved. So, okay, so now I have a good idea how the graph looks like. And there you go.